Get my table going. You understand that everything is summarized in the table, so once it is summarized in the table, you don't have to write it on the side. That the function is increasing, I see it here. You don't have to write again. So between negative pi and pi. Very good problem. Okay, so this is a trig function. Cotangent is cosine over sine. So let's see what we can do with that, because I'm assuming that they want the x-intercepts as well or not. If they don't want the x-intercepts, I don't have to find them.
No, it didn't ask.
It didn't ask. Very good. So in that case, then we can directly go to f prime. So f prime of x is 7 cosine x. And then cotangent, can anyone give us the formula for cotangent?
Was it secant squared? Cosecant squared.
Right? So sine prime is cosine prime is negative sine, tangent is secant squared, cotangent is negative cosecant squared, secant is secant tangent, and cosecant is negative cosecant cotangent. Is that okay? Okay, so now I have to find something here, because first of all, I have to change cosecant. So anyone remembers what is cosecant equal to? 1 over, if it starts with C, if it starts with C, it has sine squared. So cosecant is 1 over sine, so cosecant squared is 1 over sine squared. So we continue, we find the least common denominator, and we multiply this by sine squared. So 7 sine squared cosine x minus 1. Now, critical numbers for this function will come from two sources. One source is when sine x equals, anyone?
0.
Very good. Where is sine 0? We're talking about the interval negative pi pi, right? So, say it again.
0 and pi.
So at 0 and pi, and 0 is right here in the middle of the interval. Sorry, I didn't mean that. Okay. Also, we look at the fact that this is 1 over sine, right? 1 over sine, so I should have done that from the very beginning. 7 sine x plus cotangent is, this is cotangent. So this is cosine over sine. So then sine x is 0, so sine is 0, the function doesn't exist, its derivatives do not exist. So, yes, sine x is 0, but it's not, sine x equals 0 is not in the domain, so that cannot be accepted. It's okay as a critical number, but from here, but it's not going to be considered because the critical number has to exist for the function. The function is not defined at x equals 0. And the function is not defined also at pi. If the function is not defined, its derivatives will not be defined there either. Okay, so then critical numbers will only come from 7 sine squared x cosine x minus 1 equals 0. It's not a friendly function at all. So what can I do here is change this. I can't solve a trig equation with 2 trig functions. So I have to change this into 1 minus cosine squared to eventually get it to be to have only one trig function in it. So I have 7 times 1 minus 7 times cosine squared. and multiplied by cosine. So then 7 cosine squared x. Not a friendly type of equation. Okay, so we have negative 7 cosine cubed, and then minus plus 7 cosine x, and minus 1 equals 0. I'll multiply by negative 1, and I get 7 cosine cubed minus 7 cosine x plus 1 equals 0. I need my calculator. Which is an old calculator. I wanted to talk to you about it. If somebody sells the TI-86, you should buy it, especially if it's cheap, because it has this poly feature, second and poly. I don't know if you can see. So it's asking me for the order, which is the degree of this polynomial. I'm going to put order 3. So 7 is the leading coefficient. The next one is cosine squared, but it's 0. The next one is negative 7. And the last one is 1. And all I need to do is just click on solve. And it gives me the 3 solutions, real, imaginary, whatever. So this one, the first solution for cosine x equals negative 1.6. That's not possible. Cosine cannot be less than negative 1 or greater than 1. The next one for cosine x is 0.92. And the last one for cosine x is 0.15. I love this calculator. They don't make them anymore. So in case you're interested or you continue with math, I recommend, if you have the chance, you get the chance, buy one. Okay, so now here I have to solve, and cosine is positive. So let's see what this is. 0 to pi. This is pi over 2 right here in the middle, and negative pi over 2 in the middle. So this is the first quadrant where cosine is positive. So I'm going to look for a solution here. And this is from, so the interval, we're talking about negative pi to pi. So this is the entire circle, right? So we're going to look for a solution here and one here, where cosine is positive. So cosine 0.92 and cosine 0.15. So this one will have 2 solutions, and this one will have 2 solutions. So where's my other calculator? Because this calculator is good for certain features, but this one, it's better for sometimes. And since I'm here, I just want to show you one other feature of this calculator that I enjoy very much is conversions. It gives you everything for length, all of it. Maybe the newer ones, and maybe I didn't research that. So it gives you for area, for volume, for time, for temperature, for mass, force, pressure, energy, power, everything, speed. So I really, really like this calculator. It's probably 20-some years old. Okay, so now we have to solve these equations. Where does this problem come from? Whoever came up with it wasn't too innovative. Okay, so I have to apply arc cosine. So the inverse cosine of 0.92. So x equals, and let me see, make sure that I am in radian. Yes, I am in radians. So 0.42 radians, of course. Now pi minus this is the other solution. X equals 2.74. But 2.74 is not between negative pi over 2 and pi over 2. Okay, now the other one. Okay, with 0.15. So x equals 1.42. And the other one with, hold on one second, so I was here. No, the other one is 2 pi actually. So 2 pi minus 0.42. Yeah, it's still out of the interval. And the other one, that's 2 pi with minus 1.42. Yeah. Let me write it anyway. 0.6. So now, so this is 3.14, and this is negative 3.14, and this is divided by 2, so this is negative 1.57, so this is 1.57. So I know where to put these numbers, right? So this doesn't fit. Well, this one does fit. Okay, so I have here 2.74. Again, I don't know how they want the answer. So 0.42, 1.42, 1.42. So how do they want the answer? They want the answer in a exact. How do they want the answer? What does it say? Anything?
It's like kind of an interval. So like when it's increasing, it was like from like I guess it would be 0.42 to 0.2 point something, like interval kind of.
Okay. Is it a WebAssign problem?
Yeah, it was when I was struggling.
Okay. So now I have to study the sign of the derivative. So I'm going to plug in the derivative, not the denominator. It will be a waste of time. So I'm just going to plug in the numerator only, because the denominator is only positive. So then sine squared, sine, so let me put parentheses. So it's 7 parentheses sine of sine x and squared, and then times cosine. Gee whiz, this is a ugly situation. Okay. So here I can plug in 0, and I get negative. Then I will plug in 1, and I get positive. I will plug in 2, I get negative. And I will plug in pi, because I can, it doesn't matter. And it's also negative. Okay, so from what I got, I have to check my numbers also, just to make sure. So this was okay. The 2.74 fits. These two fit. This one does not. 1.42. I think I'm okay. I can check with the graph, but I think I'm okay. So it's increasing. Again, I have to find the numbers, right? I have to find this, I have to find this, I have to find this, and I have to find this. But they're not really asking anything else but the increasing and decreasing. So if I find these corresponding y values only if I need to graph. I don't have to waste my time to determine these and plug them in the function. For negative pi over 2, 0.42, 1.42, 2.74. Okay, now when we go to the second derivative, this is even worse. Gee whiz. So this is my first derivative. This is my first derivative, actually. So I have negative 7 sine x. And now I have to differentiate negative 2 cosecant x, and cosecant prime is negative cosecant x times cotangent x. Wow. Negative 7 sine x, positive 2 cosecant squared cotangent x. So cosecant is 1 over sine squared. Cotangent is cosine over sine. Okay, wow. So this is negative 7 sine x plus 2 cosine x over sine cubed x. Are you sure that this is the function? I'm not disputing anything. It's insane. So negative 7 sine to the 4th plus 2 cosine x over sine to the 3rd. Wow! So now I have to set this equal to 0 and solve this equation. Wow, okay. So, negative 7 sine to the fourth x plus 2 cosine x equals 0. I have to change this into 1 minus cosine squared squared. Somebody was very mad when they created this problem. So 2 cosine squared x plus cosine to the fourth plus 2 cosine x equals 0. Negative 7 plus 14 cosine squared minus 7 cosine to the fourth plus 2 cosine x. So 7 cosine to the fourth plus 14 cosine squared. This is positive, this is negative because I changed the sign. So this is negative. I lost my prop. I found it. So positive, negative, now another negative, and plus 7 equals 0. Wow! Fine. No, not this one. This one. Second poly, it's degree 4. Coefficients in order 7, 0, negative 14, negative 2, and 7. Solve. Yes, we look at, even the calculator needs time. Come on, come on, come on, come on.
So I'm assuming this problem won't be on the exam.
I know that's all you care about. I know. Just kidding. So I got that cosine x equals 1.26. Not possible. This is an imaginary number. This is an imaginary number. Okay, we got one. Cosine x equals 0.73. Okay. Okay, so we got one solution here. But is that possible? Degree 4. Degree 4 cannot have... Oh, yeah, it has two real solutions. That's correct, but this one is not acceptable. You understand that degree 4 cannot cross the x-axis once. It has to cross twice, 4 times, or none at all. It cannot have one, but this one is not acceptable, so that's correct. Two solutions. Okay, so now I want cosine inverse 0.73. Okay, so I got that x equals 0.75. Somebody was really mad when they created this. Oh my goodness, 0.75 is right here. Okay, so now I have to find the sign of this function. Where's my first derivative? I'm going to plug it in and plug in numbers in it. If I plug in 0, let me see what happens when I plug in 0. This is positive. Okay, so let me see what happens when I plug in pi. When I plug in pi, this is 0 and this is positive. Uh-oh. But is it possible? So with 0, this is positive. With pi, yes. It's cosine. Yes, negative. Okay, so the inflection point, but again, I don't know how they want the answer. They want, we can only give approximations here. Okay, so I got that the function is concave up between negative pi and 0.75, and it's concave down between 0.75 and pi. It's decreasing between a negative pi and 0.42, union 1.42 pi, and it's increasing between 0.42 and 1.42. Now, again, I always determine these numbers just to check my signs, because the signs could, if these two rows don't work well together, then I'll say, oops, I have an error. So I will still put in the function, which was 7. I need to check my numbers. Sine x, and then plus, cotangent is cosine over sine. That's the only way I can enter it. Or 1 over tangent, actually. I can. Okay, so now second in table, and I just want to plug in negative pi. And yes, of course, that's also undefined pi or negative pi. Correct. So I'm going to plug in 0.42. Let's see what happens. With 0.42, I have 5.09. With 1.42, a sigh of relief, 7.07. Let's say with 0.75. With 0.75, yes, I get 5.8. So I'm okay there. Let's check with 2.74. Yes, okay. So I feel better, because the numbers I get are increasing from 5.09, 5.7, 5.8 to 7.07 here, and then after that decreasing to 0.38. Yes, 0.38. So I feel pretty comfortable with the numbers I got.